All right, so I'm going to talk about the development of a social brain during adolescence. And I realized, because I'm the first one talking about this, that I'll probably try to introduce things more generally for the social brain. So first, just the outline of my talk. At first, we'll start by talking about why adolescence, why is it an interesting period to look at. And then I'll try to contrast the fact that they're finding of early development of theory of mind versus quite a prolonged structural development of the social brain regions. After that, I will talk about neuroimaging of social cognition in adolescence, and as well as then present a novel task, social cognition task I've been using, both to study sort of behavioral development, but also in terms of neuroimaging. So to start with, why adolescence? So there's a link between adolescence and mental health that makes it, for us, a particularly interesting age period to look at. So, for example, 75% of adult mental disorder has its onset before 24 years of age, and mostly during adolescence. So this is showing a representation of a range of onset for different disorders. And you can see that I've kind of tried to highlight here adolescence. And for a lot of those disorders, there's a significant sort of portion of the onsets that are occurring during adolescence. So to study what's going wrong, maybe in terms of adolescence in this disorder, it's also quite interesting to understand what's a typical development in this age range. And another aspect is that the leading causes of death in adolescence are accidents, violence, and suicide, and all of them you can relate to behavior and mental health. And so we think another aspect that's particularly interesting. And further, adolescence seems to be quite a critical point in development, and that relatively few problems are found during childhood. When children tend to be quite well behaved, they feel good about themselves, and they do quite well in school. But in contrast, the early adolescent years are marked by increased antisocial behavior and declines in self-esteem, school engagement, and grades. There's quite a lot of sort of people wondering what's that linked to, whether it's really kind of biological aspects or maybe more to the fact that quite often in different countries you change school around this age. And so whether this kind of major change is also leading to some of the behavioral changes that are observed. But there's still need kind of more to be done to understand more about this. So which aspects of cognition are relevant to adolescence? This is quite a sort of phony representation about what's going on in a teenage brain. And you can see quite a lot of it has to do with social cognition. So you have the cool gauge, fitting in, self-image, which one the other one? But love for the parents or not. And a lot of sort of these aspects are to do with what's going on, like the adolescents are developing sort of more interaction with their peers, and it's becoming more and more important in their life. So we think social cognition is quite important. And also I've been studying as well cognitive control aspects that I'll mention a bit in some of the tasks I'm going to talk about, but it's how you're actually controlling your behavior. And you can see here, it's supposed to be, it's like the little things. So judgment gland and peer pressure resistance. So there's maybe the idea that that's not going very right. During adolescence, it's still improving or changing. So first, just a very broad introduction about the brain. So there's frontal lobe, parietal lobe, occipital and temporal lobe. So today we'll talk mainly about the prefrontal cortex and the temporal lobe regions. So, the next part of my talk, just in general, so theory of mind can be defined as the understanding of our own and others' mind. And some aspect, which is the aspect of social cognition I'll be focusing on today. And it's quite impressive how automatic some aspects of social cognition are. So if you watch this little video, some of you might have seen it before, you're just seeing little triangles moving around in the screen. But when it's used in a task, and when you ask participants to explain what happened in the video, to describe what happened in the video, most of them are going to come up with a story like, oh, well, it's the mom and the child, and they're in a house, and the child doesn't want to go out, and the mom is trying to coax it to go out of the room, and then afterwards they're like quite happy to be outside together. But they're just little triangles, right? So it's quite impressive how strongly we kind of attribute mental states to these just sort of animation. So that's kind of one aspect of social cognition, just to kind of introduce it generally. In early childhood, typically people have studied false belief tasks, and that's what's really been used to study early development of theory of mind. And I don't know how, do all of you know this task? No? Yeah. Okay, so this is called the Sally-Ann task, and the idea is that you have little puppets and to describe the story. So you have, this is Sally, this is Anne. Sally has a basket, Anne has a box, and Sally has a marble, or usually it's chocolate. So Sally gets a chocolate, it's more important. Sally has chocolate and puts it in her basket, and then she goes out for a walk. While she's away, Anne takes the chocolate and puts it in the box. And so now Sally comes back, she wants to eat her chocolate, and where will Sally, the children are asked, where will Sally look for her chocolate? So before the age of 4 or 5, children typically say she's going to be looking in the box. That's where the chocolate is, that's where they know it is, but that's not where Sally thinks the chocolate is. Only after age 5 will children reliably say that she's going to be looking in the basket, because they're able to sort of represent the idea that Sally has a different mental state from them, and that might be a false mental state or false belief. So this task has shown, because it's been used a lot, and has shown an interesting effect, but still in performance, it's reached as age 5. So basically, there's no more improvement after that. So you can see it, first of all, in this meta-analysis by Francesca Happe. Here in red is the proportion, the probability of passing, so they collapse a lot of different studies looking at sort of false belief tasks. And you can see that basically in a couple of years, from getting it wrong all the time, children get it right. So by age 4 or 5, they just, more than 80% of the time they get it right. This is just, in the case of autism, what happens is that you see kind of a shift in a delay in when they're reaching this better performance on this task. So it kind of raises an interesting issue that by this stage, it's seen that in this type of task, you don't see any more improvement. By age 5, children seem to be doing it as well as adults. And so now I'm going to talk about the social brain. So, for example, using this task, comparing the videos where you see this little animated triangle that you can give a story to it, compared to a condition where they're just drifting around and there's kind of no obvious scenario you can give to them. This is the kind of pattern of activation that you can observe when you compare these two conditions, when people are just watching it in a scanner. They're not doing anything, they're just watching these videos. And you can see activation in temporal pole and amygdala region, the posterior superior temporal sulcus and temporal parietal junction regions, as well as medial prefrontal cortex region here. So these are part of the social brain, and this is, for example, kind of a recap of all the regions that are commonly recruited in social brain tasks. And so again, there's amygdala, medial prefrontal cortex, as well as some activity in the anterior cingulate cortex, anterior insula, anterior temporal cortex, and then the sort of superior temporal sulcus, TPJ region, as well as inferior frontal gyrus and intraparietal sulcus. So something that's quite interesting is that depending on what task you do, this is kind of an overall view for the social brain, but depending on the task you do, you might have a slightly different sub-network of the social brain that is recruited. So in the task I've just shown you before, there was particularly in the medial prefrontal cortex, amygdala, and temporal, posterior temporal region. But if, for example, those tasks that try to look more like type of mirror neuron activity, if they do exist in humans, they might look more, for example, fine IFG region that we might typically not observe in the more theory of mind tasks. So this is kind of the global network, but there seems to be kind of subdivision within this network. So what happens to this social brain during development? Well, first, in general, what happens during development is that from birth to the first few months and first few years of life, there's a very dramatic increase in connection and synaptic density. So you can see here sort of slices from postmortem brain, and that the number of neurons actually doesn't change much during this age range, but you see an enormous sort of increase in arborization, so the connection between all the different neurons massively increase. So this is represented in this graph. So again, so this is the number, the synaptic density, and you can see it increase very rapidly in the first few months and few years of life, and then it decreased afterwards. And what's quite interesting, and although you can see here there's very few data points, right? So it's postmortem studies, and you can see, well, actually there's nothing here. So it's quite hard to know whether that is the best fitting graph. But there is some indication that the prefrontal cortex, which is one of the regions sort of I'm particularly interested in, and that is involved for social cognition in the medial part, shows a more delayed decrease in synaptic density compared to more sensory areas. So, and this nicely has been sort of replicated. So this is quite an old study by Hut and Locker, and it's been replicated in another postmortem study, and they do show kind of a similar aspect of a prolonged decrease in synaptic density reduction during adolescence. So these are postmortem studies. They're really difficult to run, very rare, and so now we've got imaging, and they did that, well, imaging can let us study healthy human adolescents non-invasively. So what does imaging tell us? Well, first, it overall tells us that both grey matter and white matter in the prefrontal cortex develop throughout adolescence and beyond. So white matter is, so here is the slice from a structural MRI scan, and you can see that, so the white matter comprises those long fibers that carry signal between brain regions. And while grey matter is the cortex surface, and that contains brain cells and connections. So this is a study, so there's a very large study done by the NIH in the States, led by Jay Geed, but this is for another example. We're looking at total brain, like volume of the brain, how they change during adolescence or during development. So this is the total brain, and you can see that actually between the age of like 5 to 25, 30, there's not much change in total brain volume. And that was one of the reasons that people thought that adolescence might not be very interesting, because actually the brain size overall doesn't really change much after late childhood. But if you split between white matter and grey matter volume, then you get a quite different picture. And actually there's quite important changes in terms of total volume that are going on during development, and even during sort of adolescence and early adulthood. So white matter volume increases, and it's thought to be corresponding partly to myelination, so when the axons are covered in myelin, and that makes, as well as increasing in axon diameters, and that's thought to speed up the signaling between neurons and potentially facilitate processing speed and learning. Grey matter, there's a decrease in grey matter volume. So one question is that, well, we think it's reflecting the synaptic density decrease that I was talking to you about before. But we don't have direct proof, because this is kind of much like averaging or putting together a very large number of neurons. But that's kind of the common thinking. So we think that this is synaptic reorganization, or also called pruning, and that it's the process of fine-tuning of the grey matter tissue according to the experience and the environment. So in general, when you get a decrease of like brain volume, you might think that this is something negative, but actually it's thought that this increase and decrease is the idea is that the brain is giving a whole potential of connections, and then only keeping the ones that are used. And the idea is that might be why the human brain is so adaptable, because we're doing this for quite a prolonged period. So the brain is sort of adapting to its environment and selecting the connections that are important for its environment. And so these graphs are total white matter, total grey matter, and total brain volume, so the whole brain together. But what studies have shown is that actually this process is not going at the same speed or the same time course all over the brain. So a bit like I showed you before for the synaptic density, it seems that different regions seem to sort of peak and decrease in sort of grey matter volume. In this case, it's like the thickness of the cortex at different time. So the first regions that mature are more sensory motor regions. So here, the one becoming red are the ones that have reached their peak in cortical thickness. And this is happening first in more sort of sensory motor region, and then spreading to parietal lobe region, and then last, the frontal lobes and the temporal lobes. And these are the two regions that are particularly important for theory of mind and social cognition. So there's this sort of paradox that on one hand, the typical sort of mentalizing theory of mind paradigms that are most commonly used to study development show ceiling performance in sort of mid-childhood. And on the other hand, structural brain studies show quite prolonged changes in both grey and white matter volumes in frontal and temporal region that support social cognition in adults. So what's going on? And one idea is that, well, maybe we don't have the adequate tasks, or we might sort of not see changes in behavior, but there are changes in sort of brain function. So for the same behavior, how the brain is functioning is different. So this is what I'm going to present now, some studies looking at social cognition tasks in adolescents. So this is an example, a study done by Stephanie Burnett in sort of the Blakemore lab where I am now. And it was looking at the development of social emotion during adolescence. So there were participants were females, 18 adolescents, age 11 to 17, and 10 adults, age 21 to 37. And there were two conditions. The contrast was in social emotions and basic emotions. The idea is that those social emotions are those that require representation of other people's mental states. So for example, guilt and embarrassment, while basic emotions are those that don't, like disgust and fear. So for example, if you're in front of you, if you're tripping in the street on something and fall, if you're by yourself, but there's nobody around, you're not going to really feel embarrassed about it because, well, you just tripped. If you do that in front of your school and everybody is looking at you, then you're going to feel very embarrassed, and that's quite different. Well, if, let's say, you're afraid of spiders, if you see a spider next to you or on your arm, whether you're alone or not alone, you're all going to be very afraid. And so the idea is that social emotions are particularly, have that extra component of sort of involving the mental states of other people. So the way the task was done was that people read little scenarios, like you laughed when your friend told you she was feeling upset, how guilty do you feel, and they had to rate it from 1 to 4. Or you pretended to be sick so you didn't have to visit your grandmother, how guilty do you feel, etc. So what's quite interesting is that the adolescents and adult participants gave the same answers. On average, there was no difference in the ratings given to these scenarios between the two age groups. However, in terms of brain activation, when they compared the social versus the basic emotion condition, there was a decrease in activation with age in the medial prefrontal cortex region. The opposite pattern was observed in the anterior temporal cortex, where the activity for the social versus basic increased with age. So this study was one of the first showing that there were that the activation of the social brain changes during adolescence, even here in the absence of differences in performance. So the ratings were the same, but brain activation while the participants were doing the task were different. And this now has been replicated in quite a few different studies. So this is looking at the medial prefrontal cortex, and all these studies show decrease in activation in medial prefrontal cortex with age during social cognition tasks. So the task cues are quite varied. So you have intention understanding, this one is the one I've just talked about, understanding irony, the mentalizing animation, so the little triangles I showed you before, judging other personality traits, or reading the mind in the eyes is like presenting pictures of just the eyes, and you have to try to guess what emotion the person was feeling. So across this broad range of tasks, you see a decrease in activation in this medial prefrontal cortex region during adolescence. And this region that's highlighted in all these tasks this is a meta-analysis by Emma Jo and Frith, looking at quite a different set of tasks. And this is looking at action monitoring, they're around here, self-knowledge, person perception, mentalizing, all of these are within the medial prefrontal cortex region that is highlighted in this developmental meta-analysis. And outcome monitoring tend to be more ventral. So overall, this sort of also they call anterior rostral medial frontal cortex region is thought to be allowing the metacognitive process of reflecting on feelings and intentions. Just to kind of highlight which region I'm kind of talking about right here. So they were kind of quite interesting, but we quite often get the criticism of, well, you're looking at age during adolescence, but adolescence, puberty might be actually quite important. So what happens if you have a sort of a girl that might be pre-puberty at age 14 versus another girl who's post-puberty at age 12? What happens to their brain development, sort of in terms of hormones? Do the hormones have got an effect on brain development? And isn't it better to look at sort of puberty stage rather than age in this age range? So quite recently, a pediatrician who's working in our lab tried to investigate this. So using the same task, trying to sort of figure out what could be the age effect or puberty effect. So just to introduce, I'll go quickly over this, but basically puberty is a biological process resulting in physical maturity and reproductive competence, and it's hormonally driven. And there's some evidence that it's partly dissociable from age. So at the same age, some people might be pre-puberty, during puberty, or post-puberty. And there's some evidence that androgen and estrogens might influence progressive and regressive events in brain remodeling. And in girls, higher estradiol levels are associated with differences in brain structure. There's also evidence that there might be divergent trajectories of growth during adolescence between males and females. So I didn't show in the graph I showed you before with the changes in gray, white matter volume, and total gray. It was putting both sexes together. But if you split the sexes, there's some evidence that in males there might be like on average a year or 2 years delay in terms of when let's say the peak in cortical thickness is happening. And there's also the emergence of differential patterns of mental health pathologies between sexes during adolescence. For example, in female, you might have things like depression that emerge in female much more than in males. So as I said, this study basically used the same paradigms, comparing social emotion and basic emotion, but at girls aged 11 to 13 only. And they were assessed in terms of physical development as well as hormonal development. So they had to sort of spit first thing in the morning so that they could measure their hormone levels. Then what they found was that in the anterior temporal cortex, which was the one showing an increase in activation with age, there is an increased activity linked to hormone levels. While in the reverse, in the medial prefrontal cortex region, there is a decrease in activation still with age. So it seems to be a dissociation between like chronological age and pubertal hormones had different influences on development of the mentalizing network during adolescence. There seemed to be a hormonal relationship with the anterior temporal cortex and an age relationship with the medial prefrontal cortex. So that's just to introduce this issue that sort of during development, those developmental processes might have sort of different link with your experience or your biological sort of changes. So why do adolescents activate medial frontal cortex more than adults? Well, they may be using different cognitive strategies. So there's ideas that the temporal cortex might be involved in remembering social scripts. So it might be that adults have lived for longer, they've experienced more things, they might have experienced scenarios that are a bit like the ones they've shown during the study, and so they're trying to recall, what did I feel when I was in kind of that situation last time? Well, they activate more the temporal cortex. While the adolescents might not have had these social scripts, they might rely instead in like imagining, trying to say, okay, what would I feel in that situation? And might recruit the medial prefrontal cortex more. Or they could be over-mentalizing in adolescence in response to the same stimuli. So maybe whenever there's something about social, adolescents just kind of really think about it all, and it's like quite important in terms of sort of the processing that's happening in the medial frontal cortex. Or it could be that there, as I said, a quite late structural development in the prefrontal cortex. There's decrease in gray matter volume, so there's less synapses in that region. Maybe that's what there's less activation. You've got less kind of processing going on, less so structurally, and maybe that's why you've got less activation. So this one I'm going to talk about today. I had a look in a different tasks, more kind of cognitive control tasks, to see whether that could be the case that decreasing activation could be just explained by decreasing gray matter volume, and it's not necessarily the case. So it seems that the link is not obvious. There can be functional changes that are not just reflecting structural changes. Yeah, I said that here. So the question, so now I'm going to talk about like a task that maybe is trying to investigate a bit more the other two options. So one thing that I find is quite particular in all the studies that show decrease in activation with age during adolescence is that they all typically require participants to make an explicit judgment regarding the mental states of a character in a scenario that was presented either with those animations or drawings or text, or they had to judge how much a phrase like unpopular described themselves, or they had to judge the person's emotion from the photo of their eyes. But in all those cases, there was quite explicit questions that they were asked to reflect on their own or someone else's thoughts or emotions. And I think that's kind of quite interesting, because in everyday life you might not constantly, but sometimes that does happen. Like if you're discussing, relationship issues with a friend, you might actually think, oh, what is he thinking, etc. But actually in everyday life, when you're taking those decisions based in like a social context, you might not always explicitly think about that. So the question was trying to find and sort of use a novel social cognition task that wasn't sort of the same explicit questions about social cognition or theory of mind. So the task as used, we call it development of perspective taking the communicative context. And the idea is that, as I said, in everyday situations, we often have to use theory of mind to make top-down decisions and select an action that's appropriate to the inferred mental states of the people we're interacting with. But we might not explicitly think about it. And it is that to make this decision and choose the right action, it requires a combination of both executive functions and social cognition. So executive functions are basically all those functions that enable you to remember goals and select actions that are compatible with your goals. So I think that maybe we need to kind of think more about that social cognition in the broader context of achieving an action and sort of achieving goals. So the task we use, we call it kind of the director task. And the idea is that this is what participants are told. You're seeing this set of shelves with objects in them, and there's a director standing on the other side of the shelves. The director is going to give you instruction to move objects in the shelves, but you have to take into account the fact that the director has got a different view from you. This is the director's view. Some of the slots have like this grey background, so the director cannot see what objects are in these slots, and he doesn't know what objects are in these slots. So when you do the task, you have to remember this, and that's what we tell to the participant. So for example, in a critical trial, the director might say, move the top truck left. So which truck would you move? The red one, blue one, white one? Okay, so half of the time, adults participants get this wrong. And the idea is that you have to move the blue one because the white one, the director can't see it. So if you're taking his view into account, he can't be asking you to move something that it doesn't know is there and he can't see. So instead, you have to move the blue truck. So that's kind of the critical trial. To get this correctly, you have to think about the director's perspective. So it's director's perspective, but in a way it's always it's also a bit knowledge, because so it's kind of not clear exactly what level of theory of mind that could be, but you still have to think about what that person is viewing or knowing. And the control condition is that there is no director here, and the rule is just ignore all the objects in a grey background. So that means here, this one is in a grey background, so you have to ignore it, you don't move it, so you have to move the blue one. So in terms of your response, it's exactly the same response. And in both cases, you have to inhibit, and you kind of have similar executive function, like control demands, that you have inhibit your response to this one. Because you want to, that's the topest struck, so you want to respond for this one, and you have to not respond for that and take the blue one instead. So we tested 178 girls aged 7 to 27 on this task. And if you just look at the kind of this blue line and this green line, which is the director or the no director, we split them into equivalent size age group. And what we found is that first, there was similar improvement in error rates for both the director and the no director in the sort of 7 to 17 age range. So that might be driven by those kind of remembering what the task is, taking into account like all those objects, inhibiting the response. But afterwards, between 14, 17 and adults, we still find that the adolescents made more errors than the adults, even though their performance on the no director condition was matched. So adolescents seem to have a greater egocentric bias than adults when the inhibitory demands are matched. So this was one of the first tasks that showed changes during adolescence in terms of performance on a social cognition task. And now quite a lot of people have asked, do you use this task? Because there is variance. Instead of having ceiling performance, there is some variability that you can try to use to study development or disorders that happen during adolescence. Right, so now we use this task in the scanner, and this one is quite complicated, so I'll try to go slowly. But the idea is that in performance, like as I said, 50% of the time adults get this wrong. But in the scanner, we want to see what regions of the brain are involved when you're doing this right. Like when you're trying to take into account somebody else's perspective correctly. Because when people do it wrong, well, we just don't know what's going on in their brain. It's not useful to sort of scan people where they're doing something wrong. So because of that, we had to change the task a bit. So how it was that we had two directors in this case. So there was one that was on your side of the shelves and one that was on the other side of the shelves. So, for example, if the instruction was move the large ball up, then if the female said that, you have to pick the best basketball. But if the male says this, you have to pick the football, right? So on every trial, and their position changed, and the voice, like whether it was male or female, changed. So on every trial, you have to think about it. You can't just apply the rule throughout, okay, and just ignore all the objects in a grey background. Every time you try, you have to try and think, okay, who's speaking, where are they standing, what are they seeing, what do they know, and then pick the relevant object. The control condition involves symbolic cues, and I won't go into detail, but basically the idea is that it's matched. So that was, if it's a male voice, then you pick only objects in the clear slots. If it's a female voice, you can pick all the objects. So we were interested in two factors. First, whether they were directors or not. So whether you were using social information to make your decision, or whether you were just using cues. Or there was just one item to be selected. So for example, the instruction was move the turtle left. In that case, it doesn't matter if it's the girl or the boy speaking. The perspective doesn't change. You can always just move the turtle. So it's kind of a simpler, in terms of demand, it's kind of more kind of pop-out condition where it's just obvious. There's just one turtle, that's the one you move. Versus when there are three items of the same, so like the balls. In that case, you have to explicitly use that information to be able to pick the right object. So what we found, so we investigated the developmental changes in the neural substrate associated with first selection, the correct action in the context of alternative options. So that was when there was 3 versus 1, so the balls versus the turtle. Whether they were the presence of social information versus just symbolic cues, which is when they were direct or just the symbols. And then the interaction between the two. So when you're using social information to make a complex decision, to choose the right action. So I'll skip over the behavioral results, but basically we didn't find any difference with age. And move on to the brain results. So in the comparison 3 object versus 1 object, we found that there was recruitment in a very large network of activation of region, frontal and parietal regions, as well as kind of inferior temporal lobe regions. And that's a network that's very commonly found for executive function and cognitive control. So here the idea is that you have to select one action. There's multiple options. You have to try and identify which one is the right one you need to do. In terms of developmental changes, we found that adults recruited left frontal and parietal regions more than the adolescents. But whether they were in a direct or present or absent condition, it didn't matter. In both cases, they recruited these regions more than the adolescents. So there was these sort of domain general developmental changes in the recruitment of the frontal parietal region supporting action selection. So these regions, they didn't really care whether they were social context or the symbolic cues. They were just sort of recruiting when they had to pick one of 3 versus just one object. So what happens in the social contrast? So if you compare director present versus director absent, so just the fact that there's 2 people standing there and giving you instructions, then you find activation in a sort of social cognition network. So here in red, all along the superior temporal sulcus, as well as the medial prefrontal cortex, quite superior region, as well as in the precuneus. So we were quite interested in this because when we were doing the behavioral task initially, quite a lot of people told us, well, it's obvious you're just rotating it. It's like spatial rotation task. But actually, so we were quite sort of neutral in like what we were expecting and like what we would get in a task. We might have got like parietal regions that are involved in that type of kind of spatial rotation, but that's not what we found. Sort of, we seem to find more like social cognition network. If anything, the parietal cortex is more activated in the absent condition than in the present condition. So what happens in terms of development in this task? Well, first, as I said, at first it's the activation of social brain associated in this contrast. But if you looked at sort of whole brain analysis, we didn't find any kind of strong age group effects. So the next step we did was to look at, for each of these kind of big cluster, we just extracted the mean activation for this cluster, and then let's see whether we find any kind of interaction with age and interaction between our two conditions. And what we found is that in the medial prefrontal cortex region, there was a 3 directed by object and directed by object by age group. So that's quite complicated. So if I try to take you through it slowly. So here plotted is the difference between director present and director absent. So if you just look at the adults first, you can see that in the adults, when there's just one object, which is like the turtle, there's no difference in medial prefrontal cortex activity. So when they just have to pick the turtle, they don't care where the person is standing, whether the front or the back, you don't see increased medial prefrontal cortex activity. While in the 3 objects activation, then you do see an increase. So when they have to use the position and the perspective information to pick the right object, then you see increased activity. Well, the adolescents, they seem to show increased activation in both 1 object and 3 object. They don't seem to differentiate whether you really do need to think about where those people are standing or whether you don't. They just recruit the medial prefrontal cortex in both cases. In the temporal cortex region, there is sort of similar trend, but the 3-way interaction didn't come up. But this difference seems to be overall qualitatively greater than in the adolescent. So in the medial prefrontal cortex, there seem to be domain-specific changes that's specific to the social cognition situation. And the result provides no evidence that adolescents might sort of use more neural effort in terms of having to compute sort of more things in the medial prefrontal cortex when they do social cognition tasks. Because here, there was no difference in the hard condition, the 3 objects. They didn't seem to recruit the medial prefrontal cortex region more. They didn't seem to say, oh, right, I need to kind of think about where they're standing, etc. That didn't seem to be leading to increased neural processing. However, what they do show is that less specific mentalizing medial prefrontal cortex activation than in adults, because they don't seem to differentiate whether they do need to use this social information or not. So this fits more maybe with an over-mentalizing interpretation of the results of the previous studies. And in terms of how to relate this, as has been found before, this type of kind of increased specialization, and this is a study by Rebecca Sachs in younger children, so age 6 to 10, and looking here in this case, the right temporal parietal junction, which she has been suggesting is really important for false belief understanding. And in this case, there were 3 conditions that they were using. People were reading stories, either stories that are called physical, so there's no people involved, or people stories, so there's people involved, or mental states, so there's people having mental states and you have to think about those mental states. So here this plotting the activation in this region, the difference between people mental and the physical condition. And there's very few participants overall, but here if you plotted the order they get with age, and you can see that in the younger participant, there seems to be as much activation in the people and the mental condition. While in the older participants, there's a more specific activation for the mental condition. So the one where the participants have to think about mental states, they show increased activation. So I think it kind of fits the same sort of pattern that you might have increased specificity of the activation in social brain for the kind of more theory of mind condition or mentalizing conditions. So going back to that question before, why do adolescents activate medial prefrontal cortex more than adults? Well, here there's maybe some evidence that they might be over-mentalizing in adolescents in response to the same stimuli. So just to conclude, changes in activation are observed in the medial prefrontal cortex during adolescence, and decrease in activations overall are often interpreted in terms of structural changes during development and pruning. So here, as I said, I've kind of tried to investigate this in a different study, but nothing has been really done directly in terms of social cognition to show that there's no direct relationship with structure. But it doesn't seem that there's an obvious link in all studies. And these trends in activation may reflect the over-recruitment of the medial prefrontal cortex in social context, whether social information needs to be manipulated or not. And in any case, the medial prefrontal cortex activation decreases. That, as I said, there was meta-analysis study that showed that all those different tasks showed a decrease. Well, actually, that might be less general, like true pattern than thought. It might be more specific to those explicit kind of social cognition tasks. That if you broaden the type of task you're using, it might have different effects. So the use of more implicit theory of mind or mentalizing tasks may be more appropriate for the study of adolescent development and the link between executive function and social cognition. So if you use maybe more complex tasks where you're not directly asking people, oh, what do they think, what are they seeing, what are the emotions, then you might find sort of behavioral and brain differences that are sort of more interesting. Right, so that's it. I'll just thank people collaborating. I'm happy to take questions.